Hey, so this is something I've been wanting to make a video about for a while. It's an old project of mine called Netboot CD for like BIOS legacy boot computers, not for the newer UEFI models. A lot of Linux distributions have these network installers where the main purpose is usually to be booted from like a PXE server, a peer network boot. But also they can be put on a CD or a USB flash drive and you can boot the installer from there, and it's usually just a kernel and an initial RAM disk. And so NetbootCD CD is just a modification of the core from TinyCore Linux, which is just a kernel initial RAM disk itself. And I just modified the RAM disk to include things like the kexec binaries, the dialog menu system, and a script that shows you a list of Linux installers that you can download and run. And then the script can also get a new copy of itself from my GitHub, and that's all there is to it, really. It's not really useful for new computers, obviously, but like anything a little bit old to even older, as long as something like Debian still runs on it. I know Ubuntu discontinued the network installer with the newest versions, but Debian and some of the others still have something that works. So the way Netboot CD works is you put in your boot media, which would could be a CD, DVD, USB flash drive, something like that. And then it loads the kernel, which is the same unmodified kernel from TinyCore, and then my modified initial RAM disk. This is version 11.1, and ever since I changed it to use TinyCore as its base, I've kept the version numbers synchronized with the version of core it's based on. You'll have seen the current version is 13.0, and I just haven't built a version of NetbootCD CD based on that version of core. But I have been updating the script. So this script version is from June 2nd, 2020. That's what comes with it. If I hit download, then it updates to a newer version from January of 2022. So your options here are a list of various Linux installers that it can load. Under utils, there's slittaz and core, which haven't been tested in a while, but some of them probably still work. This is a tool for viewing and releasing IP addresses, which can be helpful in some situations. And then, of course, download and provision, which is for running a custom script, and quit. So, I've booted this CD up. I just want to install, maybe Debian 10. So I just put Buster in there. It downloads the kernel and it downloads the initial RAM disk. And then it'll use kexec to just boot from this Linux environment right into the new one. And so ultimately, even NetbootCD CD in most cases isn't the most convenient method to do something like this, but it works at a much higher level. It's actually booting what's technically a full Linux distribution, just for the purposes of booting into another. It isn't known that Debian 10, by the way, the installer doesn't like this graphics card. Debian 11, it's actually been fixed, so I'll show you that in a bit. Let me just turn this off and back on. Because NetbootCD CD is based on TinyCore, there's also a build of it that combines it with the Core Plus distribution that they have. And I've actually this is an older version I have on a CD here. It's version 9.0, but it'll show you what I mean. So Core Plus adds to TinyCore, besides just the graphical environment, also a variety of things like Wi-Fi drivers and all that. And so the way NetbootCD CD works with it is basically Core Plus I don't think it modifies the initial RAM disk of Core, it just passes arguments to tell it to load certain packages off the CD. And NetbootCD CD only modifies the RAM disk. So ultimately what ends up happening is it boots into the Core Plus graphical environment, and then you can just, from there, exit to the prompt, and then run that netboot command you saw me run earlier to bring up the NetbootCD menu. And so you could this way, if this build of Core Plus lets you connect to your Wi-Fi. You could use it to get connected and then download the network installer, which hopefully has its own drivers to connect to your Wi-Fi, because at that point you've essentially rebooted and you won't have the connection anymore. You'll notice also that was a 8cm CD, because even Core Plus, which is the biggest distribution TinyCore has, still is under 200 megabytes. So exit to prompt, and then I can just type in netboot, and then I can run essentially the same steps as before. And this is, actually I believe this is Debian 11 it'll be downloading, so we'll see if that looks any better. Yep, that does look better. So I think the other reason I want to make this video, and the thing that might be most immediately helpful in some maybe unusual cases, is that Netboot CD doesn't just boot off a CD or DVD or USB drive. There's also a version of it that boots off of a set of 7 standard 1.4 megabyte floppy disks. And so the way that works is, well, I guess I'll let it run, and then once it's started, doing its loading, I'll switch over and I'll show you what's actually on the disk. You'll see here that it's actually booted right into DOS, and the first thing it'll do is basically set up a RAM disk, and then it'll start copying files. So let me switch over to, this window, you'll see this is the script that builds the floppy image. You'll see something interesting down here. Is it up here? There it is. So with this particular image, what the floppy disk is doing is loading a kernel initial RAM disk. It's a lot like Netboot CD itself, but with 2 differences. First of all, it's based on an older version of Core, so that if it's on 7 floppies instead of 8 or 9. Second, instead of loading the Netboot CD menu, it downloads and boots the newest version of the actual Netboot CD kernel and initial RAM disk, version 11, I suppose it would be. And you'll see right here, it's actually getting the URLs to download the kernel and the initial RAM disk from the kernel command line. And I'll show you in a bit why that's interesting. So here's the contents of the disk. The config.sys, all this does is load the high memory driver so it can set up the RAM disk. Autoexec.bat then sets up the RAM disk, and it sets it to a certain size, which is actually calculated to be the exact amount of bytes it will need. And then it copies this batch file to the RAM disk and then runs it. And this batch file is where most of the work actually happens. So it copies 2 executables to the RAM disk. The first is chunk.exe, which will split a large file into parts based on its size, or put them back together. And so the first thing it's going to do is put back together these 7 parts, part 0 through part 6. The reason part 6 is on the first disk is because every other part is going to be the biggest file that can fit on a fat formatted floppy disk, whereas this part is just going to be what's ever left over. And if there's any free disk on if there's free space on any of these disks, it should be on disk 1, because this disk 1 is the bootable disk, and that's the place that would be most convenient for the user to add some files or utilities of their own. So part 6 is on disk 1, and then part 0, 1, 2 are on disks 2, 3, 4. basically. So let me just put in disk number 4 here. So chunk.exe is used to put those 7 parts together after they've been copied to the RAM disk. But it's also used to split it apart into 2 files. Instead of using any sort of archiving or combining format like zip, all I do is look at whichever file's bigger, the kernel or the initial RAM disk, and it's the initial RAM disk that's bigger. I put the bigger file first, and then I tell split to split the combination of the 2 files at exactly that point. So I end up with a chunk of that size, which is the initial RAM disk, and a chunk of the smaller size that's left over, which will be the kernel. So this is really, well, then of course I also copy linld, which is that's how you load a Linux kernel from DOS. And then this text file, kernelcl.txt, I'll show you in a bit, that's just the command line that linld will use. The rest of this batch file is really just in sequence asks for each disk and copies the part file on it to the RAM disk. Once we're done with all the disks, it'll switch to the RAM disk, use chunk to recombine the files into one file like we talked about, and then split it into multiple, split into 2. And so this will be the size of the initial RAM disk file, and then the kernel will be the smaller file. So here's your initial RAM disk, here's your kernel, and then linld loads the kernel command line from this file, kernelcl.txt. So the arguments here are quiet, which just reduces the amount of log messages printed to the screen by the kernel. And then these 2 parameters, kernel URL and init DURL, which you saw right here. And what those do is they tell this initial Linux loader, this like modified old version of core, where to actually load the kernel and initial RAM disk from on the internet. And so here, since this is the floppy set for NetbootCD 11.1, it loads the kernel initial RAM disk for NetbootCD 11.1 from, this is lacora.nfshost.com, which is just the alias for lacora.us. And you'll notice it's not loading over HTTPS either, it's just plain HTTP, so we don't run into certificate problems with the old certificate chains. But the point is, you could easily edit this file on disk 1 and change these 2 to whichever URLs you like, as long as the second stage boot environment can get to them. It should be able to then boot into them and use that as stage 3. So in summary, stage 1 is this FreeDOS environment on the disks. Stage 2 is an older version of core that's been modified to load NetbootCD. Stage 3 is NetbootCD itself, and then stage 4 is the thing you actually want to use NetbootCD to load. The only other file on here, it might not be clear what it's for, is mini.list. Long story short, this file doesn't actually need to be here. It's left over from when this floppy set used grub for DOS to load the FreeDOS kernel. And now it's just loaded kind of the normal DOS boot way with the boot sector. I accomplished that, but just by making a bootable floppy disk that was blank and then using that static file in the build process. So this is disk 7, it's copying part 5, and that is the last disk. So once this is done, it'll boot right into the the second stage. And you'll see that on the screen shortly. You can see right there, it split the file. It can recombine the files and then split the file to 2. And you can see as it was doing it printed out the numbers of bytes. So one thing both of stage 2 and stage 3 will do is it will try to access the website example.com before continuing to make sure you have an active network connection. And they'll just keep trying that indefinitely until it succeeds. Downloading NetbootCD now, and now it's booting into it. So this will be based on Core 11.1. And so all I'll do here is I'll plug my main keyboard back in. Let's see if I can take that disk out. You see, this is just an 8cm CD, so it's like 200 megabytes capacity. Netboot CD itself only needs, I think, under 20. I don't remember. It's pretty small. So I'll download the new script, and then I'll load the Debian installer like before. And yeah, at this point, it's just like if you had booted Netboot CD normal from a CD or a flash drive or a CD image, I suppose. That's one case where it could still be useful in setting up virtual machines from scratch, I suppose. All right, everything looks good. So, yeah, I think I'll reboot one more time just so you can see the exact makeup of the actual disk one. I want to show you how much space is left over on the disk. So I'll boot into Windows for that. So here's disk 7. You can see that it's showing as entirely used, which is true. Any space that isn't taken up by the file system or error checking or any of that internal stuff is taken up with the part of the file that's on there. And then this is disk 1. It's just under halfway used, so you could absolutely add like maybe a DOS game to it. You could put Grub for DOS back on there. You could fdisk. I don't know, whatever you want to do with a FreeDOS disk. It really doesn't even have to be FreeDOS. You could do MS-DOS something. You could do a newer version. The floppy disk is really kind of yours to take apart and put back together as you please. Maybe you don't even use it to boot Netboot CD. Up to you. Yeah, so that's really what I wanted to show off for the most part. I hope this is helpful, even if it's 5 years from now, maybe someone will find it useful or at least informative. And I guess if you have any questions, you can comment, I guess, or just go to the Netboot CD website, lakora.us/NetbootCD, and I think I have contact information on there. So yeah, I'm looking forward to be contacted in like 15 years by one of the 3 people who saw this video. Until then, hope you have a good day.